everyone, my name is Mayukha. I'm a software engineer at Ripple on the interoperability team, and we're focusing on sidechains at the moment. This talk will be focusing on how to design your own custom sidechain. So how do you add a new feature to the XRP ledger and deploy it as a sidechain? So I'm going to give a little bit of a presentation, an overview on how you do this, then go over an example feature. Then you guys will all have some time to come up with solutions to your own ideas. Then there might be a Q&A in the middle if that, based on time. Then at the end, a couple of you guys can come up and demo your own idea. As just a quick overview, what is a sidechain? A sidechain is an independent ledger parallel to a main chain. It's got its own consensus protocol. This the baseline of this would be the XRP ledger consensus algorithm in this case, but you could implement your own version of whatever consensus you'd like, proof of work, proof of stake, something else entirely. It derives its value from the main chain, and it can have custom features, which is the focus of this workshop. How do we build these custom features? Modifying the ledger. This is what we're all here for. So how do you add a new feature to the ledger? This is mainly done via transactions. This is, transactions are the main way that you modify, you add new transactions when you want to add a new feature. This, of course, is a little bit of an oversimplification. There are also ledger objects and requests and all that, but I'll get to that in a moment. And one example of this is hooks. So for those of you familiar with the new hooks, the new hooks feature, that is done, you add a hook via a transaction. There's a new set hook transaction that will be added to the ledger whenever hooks are approved. But what is a transaction really? Let's get to kind of the general views of that. So a transaction is the only way to really modify the XRP ledger state. It creates, modifies, or deletes existing ledger objects, which, objects on the ledger. It commits data to the ledger that users and servers have access to, and it's submitted by an account. Everything in the XRP ledger ecosystem is done via accounts. So transactions are also submitted via accounts. You can see kind of the general fields of a transaction in this JSON on the side. Every transaction, there's a transaction type, that's just the name of the transaction. It's got the account that submitted it. It's got a fee that you pay in drops. It's got flags. Not all transactions have valid flags, but they all have a flags field. It's got a sequence number, which is related to submitting a transaction. And it's to ensure that you don't accidentally submit a transaction twice. And then it's got the signing public key and the transaction signature, which are how you know that the transaction was actually submitted by that account. So ledger objects are how the XRP ledger keeps track of on-ledger data. It's, an object on the ledger. And these must be owned by an account as well, just like everything else. The exception to that are amendments, but pretty much everything else is owned by an account. This is what an example ledger object looks like. It has a ledger entry type, which is the type of the ledger object. It's got an index, which is basically the ID of the object. And it's got a flags field. Again, not all ledger objects have valid flags, but they all have a flags field. Then most ledger objects have an account field. That's just what account owns this object. There's a previous transaction ID, which is the last transaction that modified that ledger object. There's the previous transaction ledger sequence, which is the last ledger in which that ledger object was modified. And the last three are just specific to the account root object. It's the balance of the account. Owner count is the amount of ledger objects that this account owns, and sequence is the current sequence number of that account. The last part of modifying the ledger are requests, or RPCs, and it's basically the RippleD API. So it's how users access data from the ledger, and it's really useful to create new APIs sometimes alongside new features. for if you want to, because then users have access to that data more easily, and it's a little easier for them to work with these new features. So let me walk through an example feature, because now that we've covered kind of the general of how you modify the XRP ledger, let's walk through an example, which this is basically what you guys are going to be doing today. So my example here is, let's say you want to solve a mystery. So every time, if someone figures out a certain mystery phrase, a certain secret phrase, they receive an amount of XRP. Just an example idea. So here is some of the transactions and ledger objects that you might want to create for this sample. So first of all, you want to be able to create a new mystery. So we have a transaction called mystery create. It has an account, which is whatever account is creating this new mystery. It's got a secret phrase hash. You don't want to submit the secret phrase itself because every transaction is public on the ledger, and that kind of defeats the whole purpose. So you want to submit the hash of it, and you could create some sort of utility function to make it easier to create these hashes if you'd like. Then you have the reward amount. So how much are people going to receive as a reward if they guess the secret phrase? Then you might have an expiry. This could be optional for what ledger number the mystery would expire if, for example, no one guesses the secret phrase by a certain time. You don't want that XRP to essentially be locked in perpetuity if someone never guesses the secret phrase. Or if you typoed the hash or something like that. So there isn't a secret phrase. So this might create a ledger object that looks something like this. It's got a ledger entry type of mystery. It's got an index and flags. The account is whatever account ran that mystery create transaction. And it keeps track of the secret phrase hash and the reward amount. The other transaction that you would need is some sort of guessing transaction. We'll call it mystery guess. The account is whatever account is making this guess, and it's got a mystery ID, which is going to be the ID of this ledger entry object, because you need to know what mystery are you submitting this guess for. Then you have the actual phrase guess, which is whatever guess you think this mystery phrase is. So yeah, that's pretty much it. Any questions before we move on to the interactive part?
So you would also need that utility that you mentioned to parse the guess into the hash to make sure it matches.
The question was if you'd also need that utility function to parse the guess into the hash to make sure it matches. That would basically be will decode itself. So you wouldn't need to worry about that as an external person. That would be in the details of the ledger code. So how many of you guys came here with ideas for features for sidechains? Raise your hands. Okay, if you didn't, here's a list. Pick one. I'll give you a few seconds to look at this list. I talked to some of my coworkers to help me come up with the list, and other things I just came up with myself. I'm not sure how feasible any of these ideas are. I have not thought too much about it, to be honest. So keep that in mind when selecting your options. But you can go as complex as you want. You can interpret it however you want. This is just to give you ideas. All right, anyone need any more time, or does everyone have an idea that they're interested in? Raise your hand if you need more time to decide an idea. Great. So what we're going to do is divide into small groups of 2 or 3 people, probably the people that you're sitting next to. And we're going to go through the feature ideas. You can talk out whatever idea that you have and try to come up with how to convert it into transactions and ledger objects. So you'll probably need a piece of paper, or you can do it on your phone or something like that. And raise your hands if you have any questions. So I'll give you maybe 20 minutes, and at 10 minutes we can come back as a group and see if anyone has any other questions. Anyone have any general questions that I can answer that might be relevant to other folks as well?
discussing when to use hooks and when to use like the transaction type ledgers. So ledger objects.
Yeah, the question was when to use hooks and when to use like transactions or create a new feature on the sidechain. So hooks are account focused. They only do things when you send transactions to an account or from an account. So if you want to do things that don't involve a specific account, then you'd have to kind of create a new feature for that.
Do they support like multisig or?
So multisig is natively supported in the XRP ledger already, so you wouldn't need to add that as a new feature. But honestly, I'm sure there are some use cases that you could do as a hook or as a transaction type. I think there's a little bit of a trade-off there, and in terms of how you do that. Yeah.
Where does the logic go? Like in this example, the rates gas matching what's passed in to the transaction in this regard.
Where does the logic go?
Yeah, where does the logic for that live? Like, does that get put on the server somewhere, or is it?
Yeah, so the technical details that would take way too long to explain, and so I'm not covering it in this talk because we'd be here for hours, are so the Ripple D is the server that is essentially the actual XRP ledger. It's the code of the XRP ledger. So you'd have to modify it and create these transactions, create these ledger objects, and do all of the kind of logic that you need to do to make sure that that every transaction you send is valid, that the transaction creates, modifies, deletes the ledger objects the way you want them to, all of that. You'd have to modify the code. But we're just thinking conceptually here. Any other questions? All right, I'll let you get back to it for a few more minutes. All right. Does anyone feel like they want to come up here and demo their idea? We got a few minutes left. Any demoers? You want to come up here? All right. I have two options for you. You can write on Visual Studio here or on the whiteboard. Can we get the mic?
All right, so we chose the auction, NFT auction concept, and this is going to be really hard to type one-handed, so maybe I'll choose the whiteboard.
Hold your laptop if you want me to. Do we have markers? Is there a marker?
I think they're on the other side.
Okay. Yeah, that's great. So for our ledger entry type, we have auctions. And one thing that really stood out to me about this whole thing is that with everything being digital and on the blockchain, this is actually a really simple.
Do we have a better marker?
Here, let me try a different one.
That's better.
Better. There we go.
Yeah, there we go.
So it's actually really simple in terms of what's needed. So we have the auctions, and then for our transactions, we have auction create. And we have auction bid. And I think for a pretty simple auction system, this is actually enough. So you create an auction, then that has an end time or date, and you have a starting amount. And you have I don't know if this is the right way to do it, but the highest bidder and the highest bid. So you have those stored in the transaction, and then those get updated.
You would probably want that in your ledger object and not in your transaction, because the transaction
Yes, that's
doesn't get
right.
updated.
That's right. I'm sorry, that goes up here. So the highest bidder stores the account information of the current highest bidder and the highest bid. And when somebody makes a bid, if their bid is lower than the highest bid, it gets rejected. If it's higher, it stays on there. And if the time is expired, they are the winner. And as soon as they are a winner, they get a NFT offer is automatically made from the account owner. So this already also has the NFT information. I think that'd be the NFT token ID. And this can all be verified ahead of time that they own it and that they can transfer it, and it all kind of built in and very neatly flows from you make your bid, and we also have the information on whether they have that money in their account, so you skip that step of having to check for funds or go to the payment step. If you bid, you are contracted to buy it, and if you win, then you get it, and it all just kind of works automatically, which is kind of neat. Yeah.
Nice. The one thing that you might want is some sort of auction end transaction that actually does the transfer, because the XRP ledger doesn't really do anything automatically. You need to have some sort of trigger. So you could have some sort of auction end that, if it's called before the end time, doesn't do anything. But if it's called after the end time, actually transfers the NFT to the highest bidder.
The highest bidder before the end time. Okay, that makes sense. And then would you just have that kind of run periodically?
Well, you would just run it after the end. Someone runs it. It doesn't matter who. It could be the winner. It could be the NFT owner. It could be someone else entirely.
Okay,
Just someone needs to run it.
cool.
Yes, question? All right, but hold on. Let's give this guy some applause.
Thanks.
Yeah, a question?
Yeah, so how should we think about time? So is there a way for us to have a scheduled way to invoke that auction end, or does it need to be triggered by the bidder to provide it?
It would need to be manually triggered by someone. That is, for example, how escrows work right now on the XRP ledger. There's an escrow finish transaction that someone must call in order to end a transaction. But it can be anyone. It's just someone has to hit that trigger.
Like if we were developing this as an app, then we could have our backend
Yes.
do that.
Yeah, you could have your backend keep track of that.
Is there going to be some, when I was doing books, they have some pre-made books. Is there going to be something similar to these types of transactions where you can kind of go download a boilerplate type something?
Hopefully, yes, yeah.
Okay, yeah, you see what I mean? Something that's done over and over. You might have to make some ads.
We're working on it. All right, I think I'm out of time, so thank you.